finish those off because it's quite nice, but you know, this one, as you can see, we want to get, probably first thing I would do is get a single fraction. And so we know that when we're adding and subtracting fractions to get the common denominator, the easiest thing is to just times these together. And when we times those denominators together, we should recognize something. What do we recognize? It's difference of two squares. So we're going to times those together, then we cross multiply at the top. So we cross multiply at the top, and can I please get everyone, I know sometimes this is you just going, oh my God, I know this, but I still get 11s and 12s who do the wrong thing. So at this point here, especially when there is a negative, you can't say, I want to go 2 take I times 2. Tristan, do you want to come and run it? Then stop talking, please. Right, it has to be this top one here, 1 times 2 plus I, and then when you've got here minus 2, you've got the bracket 2 take I. One of the simple things I can do to make sure that people, and when I say people, I mean you guys, are checking and you're good with your subtraction and adding of fractions is I would put a 1 here. All right, so if it was like 2 over 3 plus 4i take, and I just go 1 over, I don't know, 2 take I. What I'm trying to catch people, not catch, I'm trying to make sure that you would realise, and it's something I do in an assignment, not so much a test because I don't want to catch you out. Yes, it's 2 take I. Do you think some people would just go, oh, this is minus 3 plus 4i times 1. They'd just do that? Some of you do it. Now, I'd like to think that after you've done the whole first principles and all that sort of stuff, that you would go, oh, no, 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 no. We're very good when we say we're taking, we must have a bracket around the whole thing. So just be wary of that, right? Would that be something that we might have slipped up on? So just be careful. So with this one, we carry on. We can tidy up the top row, 2 plus I, take 4 plus 2i, and then downstairs, if you recognise it's difference of two squares, you can straight away go, well, that's going to be 4. Minus times a plus. Here's your little tip. You can always have the minus and you can turn a minus into a positive, but you can't turn the positive into a negative. So I times I, that's minus I squared. Oh, minus 1 becomes plus 1. That's how we do it. Well, that's how I do it anyway. All right, so now we end up with that's minus 2 plus 3i all over 5. And we're done. Okay? You are going to continue to get... I just stopped then because Lamb is typing furiously over there. That's not what I'm actually asking you to do at the moment. That's on video. So open your book, shut your laptop, open your book. Right. So... the rest of you could listen. Lamb, you're going to write everything down. I'm tempted to say now you have to write it down twice. Last week of the term. Don't poke the bear. All right, so we want to find real numbers, x and y. As I said, this is in your textbook with the example. The first method they do it works only for a few situations. Okay, so what they do is they go, well, we want to get x and y by itself, so I'm going to get rid of this times 2 take I. And how can we get rid of a times 2 take I? You're going to divide by 2 take I. And you go, well, that's really good. So it'll be x plus yi, and we end up with I times 1 over, so we're dividing by 2 take I. I don't know why I wrote it like that, actually. I don't know. Still upset with the not having the books out, I guess. We have it like that, so we've divided by, and now we do what we were just doing before. We go, ooh, that's a little bit rude. We can't have a negative, an I downstairs, so to get rid of the I, we shall multiply by the conjugate. Go, well, this is just jolly good. This is just what we've been doing. No degree of difficulty whatsoever. So we go x plus IY. I don't know why they've run YI. I like an IY. Once again, difference of two squares. So we don't have to do the whole, it's just 4 plus 1. And then we've got I times I squared is minus 1. I times 2 is 2I. So we've now got x plus IY equals minus 1 over 5 plus 2I over 5. Do we agree? And this is where we now do the whole equate the real and the imaginary. So on your left-hand side, and I like to make a production of it, on the left-hand side, what's your real part? X. And on your right-hand side, what's your real part? So x is minus 1/5. Right? So simple, so simple. Don't mock me now, but here's my, doesn't want me to write. Right, imaginary. What's my imaginary part on the left-hand side? It's the IY, but I'm going to ignore that I because that did its job already. It told me that's the imaginary part, so I'm just looking at the coefficient. What's the imaginary part on the right-hand side? 2 over 5. And we go, awesome. Simple, 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 right? Why did you even need to go through this? Well, all it needs to do is have something like B, where, I mean, could get... Not a hugely excellent example there, but it could also be something like, what happens if I had x plus 2I and then y take 3I equals whatever. If you want to then try and times and get rid of the times by dividing by the conjugate and you've got letters in there, it becomes a little bit of a nightmare. So we have a better way, and that is just we expand both sides and then we equate the real and the imaginary. And we do a little bit of algebra. So sometimes you might have some simultaneous equations that you're going to have to solve. I probably still do that. I mean, this is easier, but sometimes I still just expand and then equate. Anyway, so let's have a look at this one. We're going to expand our left-hand side, and now because you were expanding with normal numbers, hopefully we can do it nicely with letters. What have I done? Have I done something wrong? The negative for I. Oh, what?
Oh, I divided by 2 minus.
Oh, I didn't put a minus there. Okay, here we just changed that. There we go. And who will be blamed for that? I mean, it's my error, but... Love you, lamb. All right, so we're going to expand. So we're going to go x minus xi. 2i times 1 is just 2i. What's 2i times minus I? So follow the lead again. We go minus. Positive times a minus is a minus. We've got the 2, but then I times I is I squared, which is minus 1, so it becomes a plus. If you want to do an extra line and put the I squared and all that sort of stuff, go for it. This is where I'm a little bit slack, lazy, whatever, mathematician, because we want to do the least amount of work possible. I'm not even going to bother simplifying. I just go, I want my real parts. So on the left-hand side, what's real? How do I know if it's real? Doesn't have an I next to it. So the real part will be the x and the plus 2. And what's the real part on the right-hand side? 5. So simple. Therefore, x is 3. Okay? Now, we're going to do the imag. What's the imaginary on the left-hand side? So negative x, right? So we're ignoring the I. That's just doing its job of telling us. I think in the textbook, Joe, they might pull out I as a common factor. I just think, too much work. Why? And then plus 2, and on the other side. Now, lucky for us, we actually already have our x. What you will come up with is there might end up being, this is going to be x plus y equals something, or x plus 2y equals, and then here we've got x and y. Simultaneous, away you go. It might be that you have a fraction or 2 times together. So one I had before, like if that was a y in here, you'd have x times y. So then you'd have to get y by itself, sub it in. You've done this algebra before, you're legends. in your own lunch boxes. Capiche? So you're going to be, once I'm quiet, no, that doesn't happen too often, you're going to go through and finito, you know, a little less chatting, a little more working. And shall we look at complex conjugates, or shall we do that tomorrow? All right.